Hello friends, my name is Yogesh.
My name is Prasanna Kumar. In this video, we are going to present our project named iMeter.
According to the current situation in Tamil Nadu, each and every EB substation have their own reading man, and the reading man have a responsibility to visit each and every home, and simply he will fetch all the readings from the energy meter, and he will later tabulate manually into the EB server. So this is what happening. So maintaining that kind of large databases will cause a huge number of errors, and also in some cases the man might be corrupted and he or she will enter the wrong reading, that is a minimum reading, into the databases.
A smart solution to address these issues is our project iMeter. An iMeter is a normal energy meter enhanced with the feature of data transmission and device controlling. In iMeter, we are focusing four main features. The first one is the power monitoring, the second one is the device controlling, the third one is the power optimization, and the fourth, last but not the least, power theft detection.
Well folks, this is the block diagram of iMeter. iMeter consists of two modules. The first one is the overall power monitoring and the second one is the individual power monitoring. In overall power monitoring, we have components like energy meter, microcontroller and an optocoupler. In individual power monitoring, we have modules like current transformer sensor and a relay circuit. So let me explain the components of each modules. So first, energy meter. The energy meter used here is a digital one. It works on pulses. So the second one is an optocoupler, which is nothing but a photo transistor. And the third one is a microcontroller. A microcontroller is just a mini computer. It just gets the input and displays the output. It has many other functionalities like processing, and here we have used a microcontroller called Node MCU.
Here the second part is about the current sensor. Here the current sensor is used to sense the current. Basically this will senses the individual power of the device, and the relay circuit is used for the home automation purpose, and also this is used for the controlling purpose. So this is a cloud part that we have used, and basically just consider this is EB server, and in this EB server we display the three entities. The first one is about the pulses, and the another one is about units, and based upon the units we calculated the corresponding cost, and then we displayed the units and costs in a graphical representation, so that the user will get the clear idea about the units and the corresponding cost. Here this is a whole setup of our iMeter. Here the iMeter consists of two parts. One is about the energy meter part and another one is about the current sensor part. Here we are using the single phase energy meter, and this is the current transformer sensor, which is used to monitor the individual device. Here the energy meter we had used is 230 single phase energy meter. Node MCU part, that is a microcontroller. Basically the energy meter is working with pulses. If the pulses reaches 320, then it is considered as 1 unit. Here the node MCU, which fetches the reading from the energy meter, and it will transmit the reading directly to the cloud, that is EB via Wi-Fi. Here the Wi-Fi plays an important role, which is used to transmit the data.
As you can see now, the energy meter does not emit a pulse since there is no load applied. So let us take a blower for instance, and we'll just work it out. When I turn on this blower, the energy meter emits a pulse, and the emitted pulse is captured and a counter is incremented in the microcontroller. When the counter reaches 320, it is taken as 1 unit, and for every unit the corresponding cost is calculated and both the data are transmitted to the cloud part.
The cloud part is the most important part, and all the transmitted data can be viewed in the cloud. Here the cloud is especially used for live power monitoring, and the user can able to view the power lively. Whenever the energy meter is loaded with some load, you can see a variation in the cloud. That is, we use the one blower. The blower is consumed around 3 or 4 pulses, and this can be viewed dynamically in the graphical representation. The reading varies dynamically since the user can get the clear idea about how much power is consuming readily.
Now let's see our second module. The second module consists of a single CT sensor. Let's see what is a CT sensor. A CT sensor is a current transformer sensor. It has the capability of measuring up from 30 milliamps to 100 ampere. So in order to test the individual power monitoring, we have chosen a 40 watts bulb, and a CT sensor is fixed in the phase line of a 40 watts bulb. The current value consumed by the particular bulb is being transmitted to the microcontroller. Now you are seeing the relay circuit. A relay circuit acts like a controller, a switch circuit. It has mainly two states, on and off.
And mobile app is especially designed for the clients, which is used to monitor the power as well as to control the devices in the home remotely. You can see the two modules is available in the mobile app. The first module is about the overall power consumption, and second module is about the home automation as well as the individual power monitoring. Here, this is the first module. We turned up the one blower that is consumed around 1 unit. It is also reflected in the mobile app, and you can see the corresponding cost of the 1 unit. So this is the first part, and then the second part is about individual device monitoring. Here you can see a button. If you press the button, then the devices in the home get readily turned off.
When I press the turn on button, the device gets turned on. Only when the device gets turned on, the values are mapped to the mobile app. So now let's turn off the button. As you can see, when I turn off the button, the bulb also gets turned off. The last goal of iMeter is power theft detection. Before seeing the power theft detection, we must know how a power is being distributed. We have many distribution companies to distribute the power. The power is distributed from the distribution station to the power grid. From the power grid, the power is transmitted to the power transformer, or simply a transformer, then from the transformer to various houses and other premises.
One of the most prominent feature in our iMeter is the power theft detection. Basically, the power is distributed from the grid to the transformer and the transformer to the houses via some poles. If the Just consider the 100 kilowatt is transmitted from the grid to transformer, the power is equally divided on all the transformers. If the power theft is occurred between the grid and transformer, we can say the sum of all the energy in the transformer and the power loss is equal to the sum of the output power from the grid. If this is not equal, then we can say the power theft is occurred between the grid and transformer. Also, we can able to predict the accurate location of the power theft. So this is achieved by the IP address. Basically, the each and every Wi-Fi seals has their own IP address. That IP address is mapped to certain geographical areas or location, so that we can able to detect the accurate location of the power theft. So in India, according to the census, nearly $16 billion has been lost due to this power loss. If we use this project, then we can able to compensate this huge revenue loss, and we can make use of those money in some other developmental works.